Hello, chemistry students. We're about to start chapter 18 over organic chemistry. Notice that I've named it Introductory Organic Chemistry. I don't think that we can adequately cover the entire field of organic chemistry in one chapter, about a week and a half. That's just ridiculous. Organic chemistry in college takes about 2 years to complete, and some people study organic chemistry their entire lives and still don't understand everything about organic chemistry. We're just going to be scratching the surface here, and that's okay. Please keep your minds engaged because this is one of the more difficult chapters. It's not going to be a breeze, but let's begin. All right, Introduction to OChem, Organic Chemistry. All starts with this guy, Jacob Berzelius. Jacob Berzelius classified things as organic and inorganic. And originally he meant them to be whether or not they came from living things or dead things, or non-living things. Things that are living, he said, contain organic material, and he wasn't wrong. Life is made of carbon, and now it is classified organic chemistry is based on the element carbon. And that's why we call it the study of carbon and its compounds that carbon makes. And really the entire organic chemistry field is focused on what's called hydrocarbons. Carbon almost always bonds with hydrogen. Why? When carbon's weak and hydrogen's even weaker. And so it bonds with what is weaker than itself, which is hydrogen. And it makes all sorts of things: alkanes, cycloalkanes, alkenes, cycloalkenes, alkynes. You can see all those down there. It makes a tremendous variety of things. We're going to talk about that in the coming sections. Let's have a fresh view of the octet rule. The octet rule says that atoms want 8 valence electrons. Now I'm going to have to bring out my pointer. There you go. Well, maybe here it is. All right, so if you know that carbon, it has 4 valence electrons. Therefore, carbon is going to need to make 4 bonds because it needs 4 more electrons. And in most cases, it's going to bond with hydrogen. So, I know it's supposed to be uppercase, but I'm recording on a laptop and it's kind of hard to draw uppercase things. Organic molecules are typically covalently bonded. If you throw a metal in there, it's going to be ionic because metals and nonmetals make ionic compounds. It's covalently bonded. It's insoluble in water. Typically, it does not dissolve. We're going to talk a little bit more about why later. They're generally weakly stuck together. Well, why are they weakly stuck together? Because look at this hydrocarbon I just made here. Carbon and hydrogen. They're the weakest things that we can come up with, some of the weakest nonmetals. Now, if we scratched out this hydrogen and all of a sudden had a fluorine, the fluorine would definitely affect how that hydrocarbon functions. You see, this is methane here. It's just a regular gas. This is fluoromethane with the fluorine. Well, that changes things. Fluoromethane acts vastly different than methane. And these are all weakly stuck together. Why? Because if the fluorine finds some lonely hydrogen over here, fluorine is going to dip, and it's going to go straight to the hydrogen. Because the hydrogen is very positively charged, the fluorine is very negative, and they're going to bond together. What's wrong with the following? Let's take a look. Okay, I'm having a bit of a panic attack looking at these things. What's wrong with the following? Think to yourself, as I go along with this, what's wrong with letter A? letter A has a hydrogen double bonded to a carbon. Hydrogens do not double bond. This is a crime. Let me get out this pen here. This is a crime. Cannot be double bonded. How about this one? Carbon needs how many bonds again for the octet rule? That'd be 4. 1, 2, 3. This carbon doesn't have enough bonds. It needs another hydrogen. And then lastly, this one hopefully becomes obvious to you. I just said B didn't have enough bonds. It needs 4. This one has too many. Let's take out a hydrogen. And it's perfect. It has 4. This has 5, and that's not good. Structural isomers. Isomers we've talked about before. When there's the same chemical formula, it's built differently. Consider C4H10 can be drawn in many different ways. And so if we have C4H10, actually let me just use Google. I'm going to pull up C4H10 drawn out. Let's see what comes up. Here it is. Just what I was looking for. Here it is. C4H10. Here is butane drawn out. All the carbons have 4 bonds, all the hydrogens have 1. It's good. Here's isobutane. Strange. Isobutane, everything is fine too. The carbons have 4 bonds, all the hydrogens have 1. It's just drawn a little bit differently. These are structural isomers. Same chemical formula. There's 4 carbons. There's 10 hydrogens, but they're drawn very differently. And they can do different things. Your textbook has you consider ibuprofen, typically used against headaches. There's 2 different ways to draw ibuprofen. There is this way here, and this way here. You see how they're backwards of one another? Very similar. Except one of them eases your headache, the right one does. And the other one is metabolized instantly. It doesn't do anything. You can take as much as you want, and it's ibuprofen. It should work, and it doesn't. I hope you're taking the right one if you're getting a headache from this lecture. You can see I'm sporting Phillies here. Go Phils. Except baseball's in session right now. Isomers drawn strangely always begin with iso. So you saw in the last example we had oops. I just had it up. C4H10 drawn out. Let's bring it back up. A butane. This is butane, this is isobutane, drawn differently. There you go. Now, let's continue on. What are all these prefixes I'm using? Well, we get these from Latin. And you're going to need to memorize these, but not really, because your test is probably going to be online. As I'm making this, we're not planning to return to school anytime soon. That could change, so maybe you do have to memorize these. You can see that one carbon, the Latin root is meth. And we're going to get to methamphetamine, which I'm sure you've thought of, the drug. Why is it called that, methamphetamine? It is a hydrocarbon. Meth means it has 1 carbon. And INE, what does that mean? Why do we call it ene? It's because it has a nitrogen and 3 hydrogens we're going to talk about. Amines later. Ethane. Propane. butane, pentane, hexane, heptane. Fortunately, you might be looking at this and saying, man, that's really complex. All these are pretty much the same, except they add dec at the end. And the only weird ones are when you get to like 20 carbons, ICOS. What in the world is that? Really, I've never used that in my career as a chemistry teacher. Once you get to something that has 20 carbons, typically they're not naming it using the hydrocarbon. They're just going to give you the chemical formula. Here you have butane and isobutane. It's essential to know these. You need to know if I have 8 carbons, it's octane, etc. And that's where we're ending. So I hope you can do 18.1 for homework, and you can buckle down because 18.2, it's going to get a little crazy. Sometime during the week I have a worksheet day, so there's going to be no lecture, and I'm going to have that worksheet for you to do, and I'm going to have kind of an online tutorial to finishing that worksheet. So, anyway, I hope that you are healthy and doing well, and go Phillies, right? So, we're done today.